Are you ever doing an organic chemistry reaction and there's a negative charge or a positive charge and you're just like, what does that come from? How do we know that that's there? Totally normal. That is formal charge. And for my OChem 1 students, you're probably just now working on this. For my OChem 2 students, this will be a nice refresher for you for when you see those negative and positive charges. Okay, so formal charge is just defined as valence electrons minus the number of bonds to the atom minus the number of electrons on the atom. And when I say valence electrons, I'm a bad chemist. I don't have a periodic table with me, but usually on the periodic table, there's numbers at the top of the columns ranging from 1 to 8, and that's where you get the valence electrons. So like carbon is in column 4, so it has 4 valence electrons. Oxygen is in column 6, so it has 6 valence electrons. You should have gone over that in Gen Chem, but in case you didn't, you can just look at those column numbers. They should be on every periodic table. So here's the formula. Formal charge is valence electrons minus bonds minus electrons. So that is bonds and electrons that are on the actual atom. So here's an example. Also, I should say some of my students say valence electrons minus dots minus lines. If that helps you, fine. I feel weird calling bonds and electrons dots and lines. I feel like I would be called a bad chemist, so I don't do it. But if it helps you, go for it. So here's an example down here of this oxygen. So oxygen starts with 6 valence electrons. You can look on your periodic table to see. So it starts with 6 valence electrons based on the periodic table, and it has 1 bond to it right there. And it has 6 electrons around it. So 6 minus 1 minus 6 equals -1. So this oxygen should have a formal charge of -1. So you should see a negative charge on an oxygen like this. Sometimes in organic chemistry, though, you'll see the positive charge there or the negative charge, and you'll have to figure out what that means. So this is a carbon. In our shorthand carbon notation, carbon starts with 4 things on it, right? 4 valence electrons based on the periodic table. So that means it has to have 3 bonds and electrons to equal +1. Well, we can already see 2 bonds, 1 to another carbon on this side, 1 to another carbon on this side. So that must mean there's only 1 other bond or 1 electron, but that would be radical, so that doesn't really make sense. So it must only have 3 things, so it's missing an applied hydrogen. So you can both use the electrons and bonds to determine the formal charge, and you can use the formal charge to figure out how many bonds an atom has. So when you're doing an organic chemistry problem and there's negative charge and you're trying to figure out where that came from or what they got, you can either reverse engineer to figure out what that formal charge is, or if you're trying to figure out a charge, you can use the formal charge formula and just calculate it quickly. As you go through organic chemistry, it'll be easier to recognize patterns like, oh, these oxygens with 6 electrons and 1 bond usually are negative, but don't worry about that. It'll